Hello and welcome to my channel. I am the Mad Computer Scientist. Today we're going to talk about algebraic problem-solving strategies, a video I've been promising for a while but I haven't had time to get around to. Before we delve into today's topic, I would like you all to do me a favor. If you have not done so already, please like this video. Remember to subscribe, and if you subscribe, hit the notification bell so you will always get updates when I post new content. Finally, if you find this content useful, please share it out. And with that being said, let's get into the meat of today's video. Pretend you are learning algebra for the first time and you are presented with a problem like this: 5x plus 3 equals 98. You're probably starting to panic and wondering what we do now. You're thinking, we have letters in our math. Oh no, what can we do about that? Well, we'll go into the steps in a couple seconds here, but for now, I would like you to keep in mind the words of British author Douglas Adams, author of Hitchhiker's Guide to the Galaxy. The first and most important step of overcoming most math anxiety problems is don't panic. Once you learn the process, these are fairly easy, and we will go over that in the next couple of slides. As soon as we have regained our composure and possibly prepared ourselves for the possibility of Vogon poetry, we can then move on to the second step, which is we need to try to figure out what we need to solve. You can change the letter to something else if you want as well. You shouldn't panic just because math is using letters instead of something else. You probably remember those worksheets you were given in elementary school where you were asked to fill out a square that completes an equation. That's really all you're doing here, except instead of the square we now have an x. Alright, now take a few deep breaths and remember the immortal words of British author Douglas Adams when he told you not to panic. Take a look at the equation. We have 5x plus 3 equals 98. For problems like this, the first thing we want to do is isolate the variable. It's okay, this isn't a form of bullying, we're just trying to make sure our equation stays equal throughout both sides. So let's take a look and see what we have. For the equation 5x plus 3 equals 98, I would start by subtracting 3 from both sides of the equation. Remember, whatever we do to one side of the equation, we have to do to the other to keep the equation equal. So since we're adding 3, we're going to do the inverse operation and subtract 3 from both sides. And that will give us 5x plus 3 minus 3 equals 98 minus 3, and we can simplify that to 5x equals 95. Good, now let's go on to the next step. Now that you have taken a lengthy break, or at least a break of a few seconds if you didn't pause the video, we can continue on with the rest of the equation. We're left with the expression 5x equals 95. You can see that we have a 5 with a variable on one side and just a single number on the other side. Now remember, in algebra, whatever we do to one side, we have to do to the other, and we also have to think about what operation we're doing to our variable because we want to do the inverse operation. For those of you who remember your math, you probably remember that the inverse operation for multiplication is division. So we divide both sides by 5. We can write this down if we wish, and remember, if you are taking a math class, math teachers love you showing your work, and it's not just because they want to make you suffer, it's because if you show your work, they can actually see what you're thinking and give you feedback about how to correct your process. They can also see if you made a simple error like flipped a sign, which people do, they are human. But in this case, we're going to do the division, and we will be left with x equals 19. Now you may be thinking that's our answer, but we're not sure about that yet. So what we're going to do is figure out how to check our work to make sure our answer is in fact right in our next slide. Checking our work is a relatively simple process. We just have to plug the value we got for x back into the original equation, and we will go through the steps on the next slide. So let's take a look at how plugging x equals 19 into our equation will work. No, we don't need to find the nearest electrical outlet. We just need to substitute 19 for any place in our equation where we find x. Remember, a variable in math is just shorthand for a number we don't know yet. So in this case, 5x plus 3 equals 98 was our original equation. In the next step, we substitute in the number 19, and we're left with the equation 5 times 19 plus 3 equals 98. That's still a little messy, and we like things to be cleaner, so let's simplify that further. We now have 95 plus 3 equals 98. And if we want to take the final step, we see that we get 98 equals 98. Now, a lot of you will be done here, but there is actually an additional step that's important. We are doing some quick Boolean algebra to determine whether or not the statement we found is true. Since 98 is indeed equal to 98, we have a true statement, which means our answer is correct. If our expression didn't evaluate to the same value given by the original equation, we know we made an error, so then we should go back and check our work. Never be afraid to double check, and personally on math tests, when I take them, I always like to take the time I am given to go back and check my work. So some of you may be thinking when you do a problem like this, that if you get a fraction, you are wrong. I did this as a student too, I do not blame you, but the truth is most problems will not work out this nicely. I, like your math books, often choose to expose you to the easiest problems you are going to do first. This is not because we want you to think that fractions will not exist in these problems, but the math books want you to build up the skills you will need to get to the fractions that will be a little harder to deal with. The process of problem solving doesn't change when we have decimals, fractions, or in later math, exact values like pi or square root of 3. And if you're objecting to me saying exact values, keep in mind that there are indeed exact values of these numbers, and they're represented by the symbols I just used. Now that we have gone over one particular problem and used some basic strategies for a simple algebraic equation, we're going to go over the basic strategies you need to use in general. So remember, whatever you do to one side of the equation, you must do to the other side. If you do not do this, you do not have an equation. Also, remember to keep the inverse operations in mind when you're working the problem. If the original expression says to add something, you subtract it from both sides of the equation. If you divide on one side, you multiply both sides of the equation by that number. And if you raise something to the nth power, you take the nth root to both sides of the equation. And in this case, n just stands for whatever number the exponent is. Try to isolate the variable on one side of the equation if possible. Once you have gone through the process and worked it out, get the result. Use the result to plug that back into the original equation. If the expression evaluated with the result evaluates to what the equation is supposed to equal, you are done. And just remember, keep calm throughout the entire process. A lot of people panic as soon as they see numbers in math, and there is absolutely no need to do that. Just keep practicing until you get the right answer. Thank you for sticking with me to this point. I know the educational videos, typically the math videos, do not do as well as some of my other videos. There will be more computer science content coming out. While I have you here, please remember to like the video, be sure to leave a comment, be sure to subscribe, and if you subscribe, ring that notification bell. If you find this content useful, or if you know other people who would find it useful, share this video out to your friends, family, students, and coworkers. And finally, since this is the Mad Computer Scientist, go out and write some code.